Hello and welcome to another section, 9.3. We are going to continue discussing our functions. And first, before we jump into talking about functions, let's review again. If you are given a set of numbers, a relationship right here, relation A, you're given these set of coordinates, and you want to find the domain and the range for each of these sets. Remember, your domain are your x coordinates. That's would be 1, 3, 5. The range would be the y coordinates, 2, 4, 6. So in relation A, your domain, D, is 1, 3, 5, and the range is 2, 4, 6. And then in relation B here, we have the domain is 1 and 2 as 1 repeats. Okay, so, 1 and 3 is your domain, and then the range is 2, 4, and 6. If we continue here, let's look at relation C now. Our domain are your x values here, 1, 2, and 3. And the range, they're all 2. Okay, and then for relation B, you've got the domain are 2, and then the range are 1, 2, and 3. That would be your y values, 1, 2, and 3 right there. Now, let's take a look at these here, E and F. Are these sets relations? No, they are not. And why is that? Okay, so you're going to have to remember, a relation is a set of coordinates. It's going to have to say 1, 3, or 1, and another pair. They're pairs of numbers. Okay, so these here are just listing numbers, 1, 2, 3, 4, or relation F here, 1, 2, and 3. Those are just listing numbers. They're not giving us coordinates. Relations, sets of relations have to give you an x and a y, or a range and a domain and a range, to give us coordinates. Now, a function is a relation in which no two ordered pairs have the same first coordinate. Okay, so as we mentioned, a relation has to have ordered pairs, and in order for those ordered pairs to be a function, you cannot have any repeats. That's basically what it says there. So functions are relations here. Okay, now let's take a look at an example here. Okay, make a circle mapping diagram of relation C and give the domain and the range. Is the relation a function? So here is our relation C. Okay, these are the coordinates we've got. It says make a circle mapping diagram. A circle mapping diagram means I'm going to take each of the domains, okay, that's my x values, and I'm going to arrange them in this circle right here. Then I'm going to take my range, or the y values, and I'm going to arrange them in this circle right here. Then I'm going to match each of these from the domain circle to the range circle. -3 to -2, -3 goes to -2. Here, -2, I'm going to connect to 3. 2 goes to 3, and then 1 connects to -3. 3 is paired with 4, and then 4 is paired with 3. Okay, this is called the circle mapping diagram. I've got two circles. My domains or x values are here. My range or y values are in this circle. And then I pair them according to what the relation says. And now you can see which numbers are paired together. Then I can write out the domain. Okay, that would be all the x values, right? So -3, -2, 1, 3, and 4. And then all my range values, -2, 3, -3, 4, 3. But of course, like I said before, you have to arrange them from smallest to largest. Okay, then they're asking, is the relation a function? Now, remember, what makes a function? A function has to be in that each of my x values or domains match with one range. There are no repeats. And here, in each of these coordinates, there are no numbers, no domain values that are repeated, and no range values that are repeated. So yes, relation C is a function. Now here, it says determine whether each relation is a function and explain your answer. So again, we're going to take a look at these, each of these sets of ordered pairs, and we're going to see whether or not this is a function. Okay, so a function means, are there any coordinates that are repeated? Okay, yes, M, the relation M is a function because no two ordered pairs have the same x. In other words, x, the x's are not repeated. They're all unique. And that's what makes it a function. Now, same thing here. For set or relation N, are any of the x values repeated? Ooh, look at that. 3 and 3. Okay, that's repeated. So, no, it is not a function because the 3 is repeated. Two ordered pairs have the same x coordinate 3. My x's are repeated right there. Now, here is relation P a function. I've got -3, 6, 1, 6, 2, 6. The y values are all repeated, right? But are the x values repeated? Yes, this is a function because -3, 1, and 2, all my x values, there are no 2 points that have the same first coordinate. All the x values are different, so that makes it a function. Okay, let's take a look at this. It says make a circle mapping diagram of each of these relations and determine whether it is a function. So, if I make a circle mapping diagram here, I'm going to take the first circle, and that's my domain or the x values, okay? -2, 0, and 7. Then my second circle is going to be the y values or the range. And I have -1 that's repeated, and then 4. And it says determine whether it is a function. Well, let's match our pairs now, okay? So here, -2, 4, 7 to -1, and 0 to -1. Are any of these x's repeated? No, they're all individually matched. There are y values that are repeated, but that's okay. That's not what determines whether or not it's a function. It's the x values that you have to watch. So yes, this is a function. Okay, now what about this? Let's make another circle map. We have -4, 4, and 5. And then here are my ranges or the y values. Okay, so the first one here, 5, 3, 4, 2.5, Negative 4 is paired with negative 3. Then we have one more. 4 is paired with 5. So the 4 here is repeated in the x circle. So that means it is not a function. You can have, for a function, you can have repeats in the y circle, but you cannot have any repeats in the x circle. Okay, make a circle graph now with these three pairs. I have 0, 4, and 5, and then negative 2, 1, and 9. When I pair each of those up, then that's going to give me individual pairs right there. And so yes, this is a function because all the x values are individually matched with the y value, no repeats. Okay, now it says find each of the following values for the function. Relation g, or function g, is equal to negative 1, 1, 0, 2, 1, 3. Okay, for relation, or function g of 1, okay, that means g of x. So this is your x value. If x is 1, that's this set right here, or this ordered pair. 1, then that's going to be equal to 3. When you have 0, okay, my function is going to equal to 2, because that's this ordered pair. Negative 1, here's this ordered pair, the negative 1 ordered pair, and then that function is equal to 1. So basically you're just finding the pair where each of these are matched with, and then your answer is the y value. Let's say that you're given now f of x is equal to 2x plus 4. Okay, and it says find the value for f of 3. That means I'm going to plug 3 in for x, and I'm going to evaluate 2 times 3 right here plus 4, and that gives me 6 plus 4, and that's equal to 10. So if I have f of negative 3, I'm going to plug in negative 3 for the x. So that's going to give me a negative 6 plus 4, and it gives me negative 2. So in other words, these equations right here mean you're just taking the value that they have for the x here, and you're plugging it in, and then that gives you the value for the function. So let's suppose we have f of 0. Okay, I'm going to plug in my 0 for the x, and then I'm going to have 3 times 0 minus 4, and that gives me negative 4. If f of x is negative 2, f of negative 2, then I'm going to plug in negative 2. 3 times negative 2 gives me negative 6 minus 4 gives me negative 10. If I have f of 2, I'm going to plug in 2 for x now. So this is going to be 3 times 2, which is 6, and then minus 4 equals 2. And then I have f of 4, so I'm going to plug in 4 here. 3 times 4 minus 4, and that's going to give me 8.